Welcome back, ladies and gentlemen, to another Murph Codes front-end developer tutorial. I'm Murph Strange, and it feels like another age has passed since we've done this. Kind of because it has. You can probably hear my child going crazy in the background. He is home for summer, so expect a lot of that. He does have a Nintendo over there he could play. But no, he's decided he's just going to make a bunch of noise in the background of my live stream because of course. Anyway, last time we were here, what did we do? I honestly have no idea. I can't remember. I do remember that we worked on this part. This little bit here is what's putting the green circles around all of the impassable wall tiles of our maze. I mean, they're not impassable yet, but we're going to make them impassable. If that makes any sense at all. I have no idea. Oh, excuse me. But anyway. Let me walk you through what that does. Just to refresh you, we've got a stroke style here of green, which is what gives it that nice pretty neon green look. And then we're going to loop through this ARG 616, because as you remember, ARG 6 is our dungeon, and ARG 616 is the listing of all of the walls in that dungeon. ARGs 0 through 15 is a listing of just the location of every tile. Let's take a look here. Okay. What this is just a data representation in 2 dimensions of the visual that we're getting here. There is an imaginary row here, or column here, that's not being used, and there is an unused row that's 0. As you can see, all the ones are nothing, but that's because we are taking code from originally this was written in BASIC, and the arrays in BASIC, their index starts at 1 by default. I think there's a way to make it so that you can do arrays with a 0 index, but the program we're basing our maze builder on, it didn't do that. It was just, in fact, the Python interpretation of the basic code, they kept that part in as well. Instead of adjusting for the unused row and column, they're just like, heck with it. We'll just start at 1 and do a direct translation. We're doing the same thing here. Might not be great code to do it that way, but it also hasn't hurt anything. So as you can see, there's just some blank space there where nothing gets rendered. You know, it's not interrupting our flow. And then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 16, 135 for this particular maze, and this is every single wall. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1, 10, 11, 12, 13, 14, 15. 2, 1. 2, 3, 4, 5, 6, 7, 2, 8, 2, 9, 10, 11, 12, 13, 14, 2, 15, 3, 1, 3, 2, 3, 3, 4 and 5 are nothing, 3, 6, 3, 7, 3, 8, 3, 9, 10, 11, 12, 13, 14, 15. As you can see, I'm just showing you the correlation between the two there. Like, it's just that simple. So how do we know where to target the circle? Well, we use our canvas's height and width and the coordinates translator that we wrote, which turns these coordinates into actual pixels on our canvas element, because if you recall, all the black is just a big canvas element that we're drawing on. Okay, we're rendering images, we're drawing on a big ol' HTML5 canvas element. That's how all of this is built. That's what it's all built on top of. That canvas element is args2. The context of our canvas element is args3, which is why we're calling args3 to begin path, do the arc, draw the stroke, that sort of thing. And why args? Why are we putting everything in args? Well, for the simple reason that we have quite a few different pages of code here. And each one of these files handles a different piece of our game. We have them all tied in through the head of our HTML document, but in order to make sure that certain elements of our code, certain variables, have kind of a global scope, we are making use of this argument array, this argument list that we are passing into the main function of each of these separate little libraries we're writing. All right. That probably is a little confusing, but don't let it, don't let it fry your brain, okay? What we're doing here is on a few of these, you'll see this nameless function, which basically just runs when the file is loaded in by our HTML document. It's kind of like, if you remember the Python tutorial we did before jumping into this, it's the main function. You know, when the module is main, it just runs this thing. This is how we do that in JavaScript. This function just runs when the file loads in, and it sets up some of these parameters. Since we have this as something we're passing in, we can attach all kinds of stuff to it, and in a lot of cases, that's all we do. We just attach a bunch of stuff to it. Pretty easy. So, what are we doing here? I think that was an experiment I was doing. Why am I being bombarded with notifications on my phone all of a sudden? I am not usually this popular. Put that on silent. Now it can just buzz annoyingly at me. Okay. Now, we are making heavy use of that args array to hold a lot of different things. We have okay, I need to see if that's something I need to respond to right now. Sorry, my Discord is going off, and there's a chance it's my nephew. Needing a ride. Because he might have to work today. Because why not? I just started my live stream, so why wouldn't he tell me this, I don't know, yesterday? I swear if it is him telling me that he needs a ride. I mean, I'll have to give him a ride. It's just, like, we'll restart this stream later. But of course my freaking phone doesn't have me logged into my Discord. Nope. Somebody else chatting at me. I'll have to get back to them later. Nothing urgent. Though, now I am signed into my Discord on my phone. So if my nephew does decide he needs a ride somewhere, he can reach me that way. Okay. Enough distractions, enough. Let's get back to this. Alright. So, what is going on with our page? Alright, when when the user clicks on the launch app, opens it up in a new tab, and in this order it kicks off the script.js, the soundboard.js, the user controls, display, sprite, dungeon map, baddies, and hero. Sorry about that. I've kicked up a lot of dust down here, so I'm trying to evade allergies and an asthma attack while I'm on stream, and also, like, having to ignore my phone being annoying and stuff. For some reason, this morning has decided to get awfully busy on me. I don't know why. Normally, I'm not this popular or busy. Anyway. So, we load up these things. What's the first one that we load up? We load up this one. This one just has some helper functions. Our standard stuff, which we may take advantage of. Don't know. But it does set up our args array. Alright, and then we have the soundboard, which I don't think I have open. No, I also don't need that open right now, but take a look at soundboard. This just has a class for playing sound. Sets the first parameter of our args list to mute, or to not mute, unmute, so that if we do add sound, we can hear it. But gives us a nice little toggle that we could probably put an icon or something somewhere on our little heads-up display, and user could click on that, music would go away. And how does that work? Well, right here, it's just true or false. And if mute is true, we would want the opposite of whatever our mute variable is to tell us if we can go ahead and play that sound. That's all that's going on there. User controls is next. What this does is just starts the option to read from our keyboard and mouse. We start with a giant switch event that gets called anytime someone stabs a key. Player control key, which is just set as a window event. We also have mouse down, mouse up, and double click set as well. Reason we're going with mouse down and mouse up and not just the regular mouse click event is because this helps set up the drag and drop. So on mouse down we do drag, which initiates this whole moving the mouse around. And then the mouse up ends that mouse moving drag event. I don't know if we'll actually make use of that in our app. I don't know if we're gonna do mouse control where we can just drag him around and have him slip around corners and stuff like that. We might. Still am not fully sure how I want to play out the whole having his movement translate. Right now, the way we have it set up is WASD. But it's a very herky-jerky kind of movement. Doesn't really... You have to keep tapping the key or you have to hold it down. And as I have mentioned in previous sessions, we're probably going to translate the way our input the way our input affects movement to be more of a increase and decrease to velocity. And his actual movement is just going to be a natural event of the frame rate refreshing. Every time we call the move function, it will draw him at a new position. And every time we call, every time we refresh the frame, it will also decrease the velocity due to natural gravity. And the way to increase velocity in any direction will be by hitting keys. That's a very complicated way of smoothing out movement. But trust me when I tell you, once we've actually done it, it's pretty nice. It's pretty smooth. It will look good if we do it that way. And we probably will, just because he's a slime cube. He should kind of glide across the floor. This is not this doesn't translate as very slimy kind of movement. Okay. And then also, oh, excuse me. We'll be able to add in animating him so he's not just a stationary face. Because if you recall, like, we have a bunch of different cells that we can work with here for all different directions. He blinks, looks left, looks right, moves up, moves down, moves left, moves right. We have cells to animate all of this. So we're definitely going to want to work on that bit, because this doesn't feel slimy, but the end result will be nice and slimy smooth, and he'll be more animated. He'll have more personality for our user. But we'll get to that. We don't need to worry about our styles. I don't think we've made any changes to that anytime recently. Update is where a lot of the action happens. This is where we draw our map. This is where we draw... Is that the next one we're on? Yes. Yes, it is. Alright, this is where we set up our frame rate, our default background, which we may change later. Who knows? We also have our default scaling. We add that scaling to our args list because it becomes flexible. Now, you may recall, if you've been paying attention from the beginning, our map, our play area, resizes itself based on the user's window size. Okay? And that's to ensure that at most sizes, if we're not taking up real estate with our console anyway, most players aren't going to do that. From small mobile all the way up to full desktop, everything just kind of scales itself to the user's screen. How we're accomplishing that is this little feat of engineering here, where we reload that HTML5 canvas element every time a window resizes. All right, as you can see from our code here, we don't actually have an HTML5 canvas element as part of our document. That gets created every time this update function is called. And what it does is it creates a brand new canvas element. Set to the height and width of our window. Absolute position, no border, no padding, nothing around it, just flush to the sides. Default background filled in. Make it the furthest into the background as we can get it. And every time it redraws this, we sample that canvas width and determine what our scaling should be. And we reset our scaling so that everything being drawn to it resizes to it. Now, we've gone with 3 stages of sizing. We could have gone with more, or we could have gone with a more fluid scaling option where it's even more incremental. But these are the sizes that we're going with, because if you remember when we did our plain website, not our game app, our just regular old website, those are the 3 sizes we went with for our breakpoints to determine the size of things on our page and how that changes our layout. So, little cohesive, you know. Now, before we slap on the canvas element, we have to delete the existing element, if there is any. And what we do there is we target this root div. This is empty. We remove any existing canvas elements. And then we add in the new one that we just created with our JavaScript here. Which, again, as you recall, should fill up the whole window. All right. And now, we update our args list with the canvas and context from that new canvas every time. We clear the board with the default background color. Just fill the whole thing in. And then we start drawing. We draw our map. This is our map. And that's just calling well, no, this gets called when the file loads in. But the draw map, that comes from our sprites, which we've also loaded in as because that's our next thing here. We load these in as args elements as well. We have 2 sprite sheets that we're drawing from, and to make it easy, I just went and made a function for each one that takes the cell position that we're trying to draw, so we can have control over which cell we're drawing and where we're drawing it. And it handles all of that quite nicely for us. We don't have to work so hard to figure out how we're doing that. All right. And to show you what that looks like, we can look at our draw map. Still looks a little crazy. But all of our, if you remember right, all of our map elements are just this row here from our Dust Bunny sprite list. And what are we looking at here? We are looking at cell X, cell Y. The cell Y for our map parts is the 7th row. 0, 1, 2, 3, 4, 5, 6, 7. And then what this math here is doing is we're taking the X that is passed in as the theme of the dungeon. Because there's a we have 3 themes. We have stony, icy, lava-y. And it does some simple math to determine if at this spot in our arg6 listing, is that a wall or is that a floor? And then it returns whichever tile that is. And then this and this are the math to determine the positioning. And what we're doing here is we're using the index from our loop to lay those out. The end result is this. So we have some very fine control over, which cells we're drawing from, where we're drawing those cells. Let's see here. Where are we at here? Dungeon map. How do we create our dungeon map? This is the part that is most heavily lifted from the do I have yes, here we go. I'm pretty sure I showed you all this when we first started this project, but this is a refresher for all of us, for me included. This is the program that we are borrowing the map drawing from. This was available in the 21st issue of the Magpie, which is a hobby magazine for Raspberry Pi enthusiasts. It's available for free from raspberrypi.org/magpie, I believe, and that's MAGPI. Raspberry Pi is, Raspberry Pi as in PI, the number. The mathematical concept, I should say. This article from that issue, Martin Hodgson has done the hard work of translating Tim Hartnell's Stronghold of the Dwarven Lords from BASIC into Python. And he's shared the code here. We have taken this code and translated it into JavaScript. Alright, and that's what's going on here. Okay? And it's almost a pretty straightforward translation. And we take literally the same array that he sets up here. We set that up. He declares a bunch of these global functions, but he kind of repeats himself a little bit here. I don't know if that's from the original, if he just kind of just copied that straight over, or if he just kind of forgot, because A kind of repeats itself a few times. Anyway, so we declare our variables. We don't need to make them functions because we're just putting all of this in kind of one big function and then storing that as part of our array argument that gets passed around to everything. But basically what you're seeing here is it takes our 15 by 15 square and it takes a few elements here, because as you notice, when we randomize this, there's some areas where you can predict that there are going to be walls. Now, this data here is what holds the template for the dungeon, and then this stuff is what kind of changes it up a little bit, so it becomes a randomly generated maze each time by just removing a few walls here and there. But the maze doesn't change too significantly. Okay, as you can see here, we have always got this wall. There's always a big section here that's got some walls. Here's a wall. This kind of always juts out, and there's always something over in this area. There's always a little bit here. It's just pieces disappear, you know? Disappear and reappear. But like right in here, almost never fills in. I don't think it ever does, actually. Yeah, no, like these 6 squares here, always floor. Many times as we want to do that, they will always be floor. Same with some of them up here and up here. Over here, I think there's another one. Those are the spots we're going to put our bad guys. Why? Because we don't have to worry about a dungeon wall suddenly spawning into their track area, you know? Because our bad guys are, surprise, surprise, going to be stuck on rails. They're going to be given very particular places where they can be, and they're just going to have to bounce around in that area, and that's it. And to make sure that they're not like passing through walls and stuff, they're not interfering with, you know, they're not getting stuck in walls. The walls aren't interfering with them being able to, you know, patrol around. What we're going to do is just try to confine them to little areas where we predictably do not have walls. It's going to make things so much easier for us. Now, we're not going to fill in every run of no walls with a bad guy right from the start. That'll be probably a thing that as we progress, we'll introduce more and more to increase the difficulty for the player. Anyway, that's how we do our dungeon map. And our dungeon map resides at ARG 6. ARGS 8, that's our dungeon type. ARGS 8. ARGS 3 and 4 are actually... No, ARGS 3 was the context of our canvas. ARGs 4 and 5 are actually the sprite itself, the sprite sheets. And what we're doing here is we're checking to make sure those are loaded before we start drawing, so we're not running into that error that we were having before of the resource isn't available. Because that was kind of a thing for a while. And kind of frustrating to deal with because our code would load faster than the image file would load. Even though it's not really much of an image file, there's not a whole lot to it. I mean, this is pretty small in the grand scheme of things. But still takes time to load that. So what we've done is we've set up a check to make sure that it's loaded, that it's not undefined, it's not null, it exists, and we can actually draw from it. Alright, so most of the work ahead of us still lies here in the update function and in our baddies and our hero class. Alright. Here we have his basic starting position, which is fine. His X and Y coordinates are going to be based on the X and Y coordinate system for pixels in the HTML5 element. We're going to redo his move function instead of just directly translating add so much X, so much Y to his current X and Y whenever we hit the corresponding key. Because that's literally all we're doing here. Walk east. Add 10. Add 10 to his X, 0 to his Y. That's all well and good, but it's not what we want. What I want to be able to do is instead of adding 10 to his X and just having it transition him over, as we said, we're going to do a velocity change instead. His move function will still where am I looking at here? His move function is still going to move him around, but it's going to be based on, instead of these key presses, it's going to be based on what's his remaining velocity. And with each frame refresh, we're going to add until it reaches a basement or a bottom floor value of 0, probably, for its velocity. We're going to have it slowly tick down on his velocity. Alright? This is going to happen at a rate of 60 times per second. So we do not need a real, we don't need to reduce his velocity by a lot. Okay? We just need to reduce his velocity by enough so that at 60 updates per second, he slows to a stop instead of just immediately halts when we stop pressing the key. Now, this is also going to set the threshold we have to overcome in order to get him moving. And so every time we hit a key, we're going to have to add that much to his velocity. So as long as they keep hitting the key, he'll keep sliding in whatever direction. Unless, of course, he hits a wall. So, this is going to be a little bit complicated. But we are going to revamp his entire movement, his entire locomotion thing. I'm already exhausted. See, this is what I'm talking about with, we're probably going to have to move this to a more than once every other week kind of thing, because when I come back to it, I have to do this whole big long review in order to not only refresh my memory, but also yours for anyone who happens to be following along with this. They occasionally get a couple of views. So I like to think there's somebody out there who's following the progress of this thing, going, oh yeah, that makes sense. I don't know what you're doing. I don't know what you're doing with your life. If that's what you're doing, good for you. Otherwise, why? What? Is there nothing else going on in your life? But, first thing we need to do is we need to set up velocity. All right. This is also going to help us be able to move kind of at a diagonal if we need to. So, like, if our player starts tapping up, but our character is still moving to the right, he'll kind of curve a little bit. Hopefully. Because we're not going to just want to immediately end his momentum in any particular direction unless he hits a wall. If he hits a wall, he'll probably stop. Otherwise, what we might do is when he hits a wall, change the whether that's an X or a Y velocity, reverse it, make it a negative, so that he backs up instead. All right, let's see here. mean, it's going to be pretty much this simple, where at 0, he's at rest. Negative values are, up or to the right. Or, I'm sorry, negative values are up or to the left. Positive values down to the right. Okay. Now I know we have this move function. And what I'm thinking I'm going to do is I'm actually going to take this move function, put it in the draw function. Well, actually, no. We don't need to do that. We can just make that naturally part of the draw function. And our move function. This does this. Now we'll probably want to tinker with our values because currently we're just doing zeros, and it's probably going to take a bit to overcome the gravity that we're going to be adding here. All right, now to draw our character, that's going to be the actual final part of rendering him. Because we're going to draw the player. But before we just go ahead and just draw him wherever he's at, we're going to need to update his position given his current vector, and then apply some gravity so that if the player isn't rapidly pressing keys, he's coming to a stop. Or if he runs into a wall, he's coming to a stop. All right? We need this bit. This is the part that's drawing our This is the part that's drawing all of those boundary circles. These are places we don't want him to be able to go. Even if his velocity is going to send him directly into it. So how do we do that? We're going to go through the list of wall elements, and we're going to make sure we're not going to draw a circle around him, though. All right, but we're going to make sure that the radius from the center point of each of these circles is far enough away from our character that he can still move, you know? Like, if he's moving this way or that way, we want him to be able to do that until he gets to a certain point where he's within the circle. And then we're not going to allow it anymore. We might have him just kind of bounce off. By reversing his velocity. Or we may just, you know, once he gets to within a certain range, end his velocity in that direction. Alright, so we're going to check if applying the current velocity helps if I spell correctly. Puts us in a wall. I mean, there's a comment, so I guess it doesn't really matter if I spell it correctly or not. Alright. Yeah, just apply drag to velocity. This is going to be the specific gravity that we give this character. And basically what this does is, whether we're hitting keys or not, the velocity will be reducing itself. And the reason we want to do that is because if we're not pressing keys, we want them to slow to a stop, right? This also sets the threshold we have to overcome in order to get moving. So whatever we set here, we have to take that into account for up here when we do move. X and Y have to be greater than the initial gravity. Now this is also going to be how far he drifts. Without any kind of like input from us, like, well, no, this is going to be how much his drift reduces when there's no input from us. I don't have a real good number off the top of my head. I don't. But I do know we do not want him to be darting a full frame or a full cell every frame. So, we'll go 5 for now. We can adjust these values as we need to. And we can actually just roll this right into here. So that we don't have to like build up momentum and just start rapidly tapping keys right off the start. Because remember, our movement is going to be more or less than 0, but not 0. Okay? If it's 0, we're not going to add any gravity to it to overcome that threshold. But what we want to do is we want our little our threshold of gravity to be factored in when we start hitting that button so that he's immediately responsive without it being a real issue. We're already adding in that. We'll do the same for y. If it's greater than 0, y equals y plus. Oh wait, I have this wrong. I have this backwards. I almost screwed it all up because I forgot my signage. Now keep in mind, this is only on the initial call of move. No, this is on every call of move. It adds in a little gravity. My child is just groaning and making noise in the background. Okay. So we have our gravity threshold built into the move. And we do a similar thing here. It's less than 0. Help if I add the thing. Okay. This dot vector x plus this dot gravity till it hits 0. Keep in mind, this happens every time we draw the frame. Like every time we draw it. So we may actually want to reduce this to like 1 to start with. because it happens 60 times a second. Caught that misspelling. Now, did I also forget to do anything here? No. Greater than 0. Okay. And actually, we're gonna put this after we draw. Alright? Because otherwise we're just canceling it out. Because here we add the gravity, then we take, or then we, yeah, no. So, there we go. Okay. Save that for now. I said save it. There we go. Now, for now, to check that this actually works, we're going to just assume no damage. So we're still going to be passing through walls. All right. But we do have our check in place. Well, the step for it, we just haven't implemented it yet. So we draw it. We add. Yeah. Okay. Still feels like it's pretty herky-jerky, right? Well, we also didn't add anything here. So let's make these bigger. We might also have to... We might also have to clear cache. Keep forgetting that's an annoying thing I gotta deal with on this. Okay, so now he goes a little far. Now he goes just a little far. Let's bring this back down to 10. But you might have noticed he does a little bit of a slide. It's smoother now. All right, I still think 10's a bit much though. So let's start with 5. Really gets going. We want to cap his velocity. All right. So right now, there's no limits to his velocity. We're just adding velocity. So. Just making up arbitrary numbers here. Oh, that should be the other way around. And notice I'm doing this after we're applying the new value because I want this to be a hard cap. I don't want us to be able to get beyond this point. Well, this is why. Ah! Jumped. Hard caps. Still seems to be a lot. Is it the settings again? Helps if I spell it right. Why is it going back to the left? Ah, because I didn't finish the... There we go. Now it should work. Movement is throttled when we hold down the key. It doesn't go any faster than that. We'll let go. He kind of slides to a stop. Perfect. It's a much more natural movement. It's a much better movement. It's not the herky-jerkiness of, you know, stabbing keys over and over again quite so badly. I mean, you might be looking at it going, well, it's not much different, but it's a little smoother. Okay, you got to remember, we're working on small numbers at this point. But when we hold it down, he gets a good run in, but it's not like, you know, he's zipping all the way across the screen anymore. And when you change direction, you notice there's a little slide there. So yeah. It's a little bit better. And we can tinker around with these numbers all day. If we want to, we can get him whipping around the screen super fast, make his slide further, whatever we want to do. But where it's at right now, I'm okay with it. I'm actually good with it. That's really what I wanted to be able to accomplish today, was get us to this point where we're transitioning now to checking for if he's going to collide with rocks and stuff. That's our next step. We need to keep him in bounds with his new locomotion. Because we've got him moving in a more natural way. At least I feel like it's a more natural way. We are going to stop here, though. I know, this hasn't been a real long session. We've only been going for about an hour and a half. But, what can I say? I've got things I've got to get done today. I'm still trying to get everything set up for my new little studio that I'm working on here. Still cleaning up the yard a bit. A lot of stuff I have to attend to today, so I'm gonna go get on that. But I am glad we were able to get this much done today, and that it didn't go horribly. So from where we're gonna go from here. We can drop these numbers down. That's a ridiculous number. Because where are we at? We're capping at 10. You're probably thinking, what are you doing? Well, I'm making it so that we can adjust gravity and the vector cap real simply right here. Just without having to go through all of this nonsense and change it every single time. So, there. And just to make sure we didn't screw things up by doing that, we did. Okay. All right. That's our little slime guy being able to move around in a more fluid manner. I know at this stage it seems super subtle. Like, you know, I just added a whole lot of extra code for what amounts to very little actual anything. But we can change the parameters now. You can get going way faster. And notice that slide takes a lot longer to get to. Like, if we wanted to. Alright, so I'm going to start here. And release. I release here. He slid that far. And that's just on half the gravity. And release. 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 Doesn't like that value because we get a little bit of a drift occasionally. See what that is our change in velocity isn't hitting 0 at all. Like, we're just not hitting 0. Still slides about a full tile if he gets up to full velocity at this rate. When I let go of the key, if I let him get up to full velocity and I let go, he'll still slide about a full tile at gravity 1. And that makes sense because at gravity 1 it takes 60 frames to fully reduce his gravity or his velocity. Approximately. Although we do have it capped though at 15. So I don't know how all the math on that works out, but this feels good. This feels fluid, and we have the ability to control and fine-tune his movement. All right. Like I said, I feel good about where we're at now with this. We will be tinkering around more with collision detection next time. I know I keep kicking that can down the road, don't I? Yeah. But it's something we are working towards. Okay? Because the next stage is going to be confining him to the maze so that he can't extend outside its boundaries, can't run through walls. We can keep him inside of the maze so long as we turn on collision detection, because the maze is fully enclosed. And as long as we make it so that he can't extend past 50% of a tile in any direction, that's got collision detection properties like the walls would, he should stay within the confines of the maze. Like, we don't have to set a massive, like, hard cap boundary of, you know, he can only go so many pixels to the left, so many pixels to the right, so many pixels up, so many pixels down. The natural order of there being a wall and him not being able to phase through a wall will be enough to keep him inside the maze. And then we can start littering it with bad guys and set up collision detection for them, give them automated action, And then we need to implement some kind of goal, some kind of objective to advance to the next level. Some kind of thing to increment the difficulty. Add some sound effects, some music. And we got ourselves a fully fledged out game here, guys. Whole lot of work, right? We've been at this for a while, actually. A very long while. This is why I don't really advertise that I answer questions quite so much as I used to. Way back in the day when I was a free code camp counselor doing the moderator thing on their Facebook group. I had no problem answering questions for the group, but it never failed. There was always somebody who thought that it was not so much of an ask that, hey, can you help me with this project I have in mind? And they want to make a full, like, Facebook clone. And it's like, dude, you do understand, this is not like just a simple block of code. This is a years-long project you're expecting me to help you out with, and you want me to just magic this into existence? No. No. I have a life to live. The ask you are putting to me right now would negate my entire existence until this is done in the time frame that you think it should be possible. It's never gonna happen. And that's always the way it is with them. Oh, is somebody like you should be able to whip this up in 10 minutes? No, absolutely not. It doesn't work that way. This is a simple game that we've been building. It's not complicated. It's just a little green square that moves up, down, left, and right. And we have been at this for months now. Just getting it to render the tiles, getting it to render this dude, getting it to move this guy in a way that feels more like a slime cube ought to. Being able to set it up so that we have a randomly generated map to play on every time we hit refresh. This has nowhere near the complexity of something like a Facebook clone or a Twitter or something. And to make it even dumber, why do they want to get into that? Why is that the space they think that they can compete in because they think they have an idea that's going to compete with them? Do they not understand the massive pockets of resources that these large tech companies have built up over the years? Like, nobody's just going to come along one day with an idea and suddenly they're going to be competing with Facebook overnight. No. No, they're not. That's never going to happen. I'm sorry. Keep dreaming, okay? And also understand the scope of what you're asking somebody when you are inviting them to work with you on a project like that. Okay? Nobody's going to have an interest in something like that. Nobody. But I used to get asked that by newbies all the time. Oh, you want to work with me on this project? And basically what they pitch is literally a Facebook clone. Oh no, but it's going to be different. It's going to be better. Yeah, dude, it's me and you working out of... I don't know, you're probably working out of some broom closet in I don't know, Nigeria or something on a 8-year-old laptop. I'm working in my basement on a computer that, wasn't exactly top of the line when I bought it. Sure, I've made some upgrades, but it's still not top of the line. It's just, it plays games that have come out in recent years, I guess, fairly well, as long as it doesn't demand super high-end graphic cards in order to, to play. Working by myself for months, and building off of a resource that already existed. This game, this map generation thing already existed. Has been around forever. Thanks Tim Hartnell for, for putting that into code, and thanks what was that other guy's name? The guy who Morgan Hodgson? Martin Hodgson. There it is. Yeah. Tim Hartnell and Martin Hodgson. Thank you, wherever you may be, for putting that into BASIC and Python so that we can come along later and turn it into JavaScript. Otherwise that would have been a whole development cycle itself. So yeah, when I say I'm willing to help somebody with their code, when I'm willing to answer questions and help you figure out what you're doing wrong with something that you're trying to work on, what I mean is have a specific block of code that should return a result that isn't returning the result you're hoping for, and not, hey, I'm trying to build an entire ecosystem and I can't figure out why the whole thing isn't working. Could you help me build it? No. Understand the scope of what you're asking first. Alright? Otherwise, you're just wasting someone's time. And, this isn't just a problem I face. This is a problem everybody faces. Whether you're on Stack Overflow, whether you're on the Facebook groups for coders, whether you're on Reddit for learn programming or whatever. Understand what you're asking. Okay? And understand if you're trying to build something to compete with, Google or Facebook or whatever, or Amazon or one of the big tech companies, you and a handful of guys working out of a garage are not going to be enough. Okay? You're going up against somebody with deep pockets, an entire army of developers, and a whole bunch of lawyers. Your project will never see the light of day, and you're wasting everybody's time who's working on it with you. Okay? I don't care what great idea you think you have that's going to be so much better than what's already out there. They'll just come along and sue you into oblivion and then take your idea. They won't buy it from you. They'll just make sure you never get off the ground, and then they'll develop it instead. So, don't do that. Okay? Make your own website, make your own stuff. Sure, that's fine. But don't be dumb. Alright? Don't try to convince people that they should help you, and waste their time with the whole, I'm trying to build a ginormous project and I want your help. And I want you to write the code for me. Because I still get that. I have a Discord that I advertise, a link to. And that's there so that people can ask me questions. You can join the Discord, you can ask me questions about stuff. But what I don't want is to take on a project. What I don't want is to help you build your dream website or your dream application or something that's going to take months, years, whatever. I've got plenty of projects of my own going on. In case you haven't noticed, I'm not going to help take on yours as well. But if you have a simple ask like, hey, I'm trying to work through this thing, but it's not working right. I think it might be something to do with the way I've worded this for loop or the way that I'm handling this this conditional check or whatever. Could you take a look at it? That's fine. That sort of ask is just fine. Might take me at most an hour looking over your code, trying to figure out what exactly it is you're trying to do. And I'll get back to you with an answer. And I'll be like, yeah, maybe try it this way. Or, give this a shot. Or, maybe I'll just be like, hey, I don't understand what you're trying to do here. This isn't making a whole lot of sense to me. Run me through that. I'll do a little back and forth with you on that, and I'll help you get to an answer. But what I'm not going to do is I'm not going to clear my schedule to help you build an entire monstrosity. I don't care if you think it's going to make $1 million. I don't care if you think it's going to put me on the map or, make me rich. I'm not interested. Like, I'll answer your simple programming questions. That's fine. And I have no problem with that. I love talking to people about code. I like helping new people to code, figure out how all this stuff works, really get into what it's actually like to be a developer, make their own stuff. Because a lot of the time you start one of those tutorials and you're thinking, oh yes, I'm going to learn how to make some cool stuff. You get to the end of it and you really haven't learned how to make anything. Sure, you understand the language now. You know how to make a function. You know how to do a for loop. You know how to do an if statement. But you're still missing the part where you put it all together, where you start a project and you solve problems with your own code. Like, these are the things that tend to get left out of coding tutorials. And a lot of the time I run into this where, oh yeah, I've taken this course and this course and this course, but I still don't feel like I know how to build anything. And it's like, because they didn't teach you how to build something, they taught you a language. And there's a difference. It's actually a pretty big difference, too. And it's kind of important that people know that difference. Because the development cycle on something like even this simple, stupid little game, where it's just a little green cube sliding around a maze. Like, this has taken months. And I started this with an idea of how I wanted it to work. I had to make all the resources myself, though. And while I knew how I wanted the map to be based off of this thing, I hadn't done it yet, so I wasn't even sure that that was possible, but I went ahead and did it anyway. And yeah, not only is it possible, it works pretty nicely. Now, we still have quite a lot to do. We still have quite a ways to go. We still have quite a few things to implement, quite a few changes to make. We have to add collision detection to his movement, and we have that laid out here. Now, this is probably the part where I may have to take this and move it. No, because the move only affects the vector. It only affects his velocity in any particular direction. It is the drawing that is going to be where we have this happen, because that's where we apply that velocity to his movement, right here. And so we're going to check for, will this put us in a wall? If this will put us in a wall, don't do it. Maybe reverse the velocity, reverse the, or bring it to 0. But that'll be next time. We'll work through that. And then we'll start adding in our bad guys. Because once we've got the collision detection for the walls, he's not going to be able to move outside of the maze. He'll only be able to move around in the maze where he's allowed to go. Like any place that doesn't have a wall will still be open, free territory. But we'll probably have to make it so that he bounces off of walls and stuff. Which is fine. Adds a interesting little element to things, like if you get a full run up and you hit that, maybe have him bounce back. I think that would be fun. Make it a little interesting. Hope you've all had fun. Watch me, brute force my way through this project. I mean, so far we haven't changed the scheduling on this, so it will be another 2 weeks before we're back to it. But when we do get back to it, we'll add in the collision detection, and then we'll start adding in bad guys. If this isn't what you're tuning into my channel for, if you're here for the, the Legend of Zelda gameplays and stuff like that, Mondays and Fridays. And speaking of which, this Friday we are still playing The Legend of Zelda Link's Awakening 2019 remake for the Switch. We have completed the game as far as story mode and all that. What's left for us to do is the gold tier down pay challenges for his little chamber dungeon stuff. And then we want to do our own little recreation of the original dungeons from the very first Legend of Zelda for the NES. We're going to try to recreate those as close as we can, given the chambers that we have available to us. It's not going to be an immediate one-for-one, obviously, but we are going to do our best to see what we're able to do, because I think it would be kind of cool just to see if we can get close, So tune in Friday for some of that. We're probably just going to be tackling the gold tier challenges on Friday. Probably won't get to actually building our own dungeons until next week. Maybe the week after, depending upon how slowly we make our way through the gold tier challenges. Some of those are tough. Not going to pretend I'm going to get through all of them on Friday. Not even going to pretend that. No, we might get through 2 or 3, maybe somewhere between 4 to 6 if we can do them quickly. But, no promises. Yeah. I'm hoping at some point here, Zeph and I will be kicking off season 2 of the podcast that we do. And trying to think what else there was that I had going on. Well, that's about it. We'll eventually be getting back to playing Metroid at some point in our lives. So, if you're a Metroid fan and that's what you were following me for, I hope you haven't been feeling like I've completely abandoned y'all on that. We just needed a break from Metroid because we played a lot of Metroid. I know at this point we've also played a lot of Legend of Zelda. But we'll get back to finishing our Metroid run. And we'll continue our Zelda run and all that fun stuff. And yeah, a whole bunch of great stuff to come. Be sure to keep checking back, see what I'm up to. Till then, y'all have yourselves a wonderful day, and we'll catch you next time.